Good afternoon, everyone, and welcome to the Construct and Innovate webinar series on modern methods of construction. My name is Jamie Goggins, and I'm co-director of Construct Innovate, which is Ireland's National Research Centre for Construction, Technology and Innovation. This week, the focus is on how to deliver sustainability at scale using 3D volumetric offsite solutions. This is part of an 8-week webinar series. We're on week 5 of the webinar series now. Delighted to have 3 eminent speakers, really leading the way in this area across different domains. So first we have Helena, who's Chief Operations Officer at VBC, or Volumetric Building Companies. They operate around the world from the US, Poland, Ireland, and so on. So a lot of experience and a world leader in 3D volumetric delivery, and it's going to really tell us about what we need to consider if we want to deliver projects using 3D volumetric. Then we have Gareth McMeekin, who's a Strategy and Innovation Manager at BuildWright Modular Concrete Homes, and he's going to talk about how to deliver at scale using 3D concrete volumetric solutions. Then we have Dr. Barry Heffernan, who's Chief Operations Officer at OxyMem, which is a duPont brand, and he's going to talk about the system that they have for wastewater treatment, which is Grow with the Flow, with OxyMem MABR. So it's a reactor for the wastewater treatment systems. So we're really looking forward to the 3 presentations. 3 presenters will be about 15 minutes each. We'll be followed by the Q&A afterwards. So if you've got any questions for any of our presenters, please do pose it in the Q&A function at the bottom of the screen. And as I said, we'll deal with all the questions at the very end after all 3 presenters. So without further ado, I'm going to hand over to our first presenter. So Helena is going to talk to us about 3D volumetric design and what we really need to consider if we want to deliver projects through volumetric design. So over to you, Helena.
Thank you, Jamie. I will start sharing here. Sorry if I'm a little bit rusty in Zoom because I normally do this in Teams. Good afternoon, everyone. I'm Helena Lidelöw, and for those of you who have ever visited Sweden, you could hear on the sound of that I am Swedish. I run the Volumetric Building Company's international branch here in Europe, and I am headquartered in Gdansk, where I'm sitting right now. This is what we do, what you see here. The numbers 1, 2, 3, 4, 5, 6 is taking you through the steps of when we have a steel cage delivered to our factory, and it's gradually being fitted out. Those of you who have stayed at the Citizen M Hotel would recognize the design that's on number 6 there. We have an internal furniture factory who's helping us doing the fit-out elements for hotel rooms. And hotels is our specialty, while we are moving in to do residential and our first project in healthcare at the moment. The hotel to the right is our latest project, sits in Iceland. Now, what we need to do here is to talk about how we move from our traditional way of thinking about construction and what challenges that poses for us. So the first difference here is how we look at delivery. So we insert this factory piece into the equation and the delivery chain, and that does change the way you need to look at the supply chain from various standpoints. So the first thing is that with modular approach and methods, you will have 40 to 50% faster site works. So that is glorious for most people because they want their project to arrive fast. But finances are the ones who struggle with this concept, given that you are producing a lot in a factory, but you're actually not producing that much on site. So where is the collateral? That is one of the biggest challenges we are discussing when we're closing projects. On the client side, you get your building quicker, means that your return on investment here, depending on if you're hospitality, you get guests in your rooms quicker. If you are doing rental property, you get, again, inhabitants coming into your building and starting paying rent quicker. So that means something on your balance sheet in the investment here. And that's one of the biggest arguments for modular, is that your We're not selling cheaper, we're selling faster. Now, the first thing we check when we enter into a project is a totally different thing, though. It's transport and logistics. Can you get there? And meaning not can, but can you get there viably on the financial side, but also from a geometrical, just are we delivering downtown London? We need to be able to understand if we actually can realize that. Now, I have factories, 2 of them, and this is one of my pain points. I want it to be running at all times. The largest investment for a supplier here is the factory itself. And if I can't feed it, that investment won't pay off. So sometimes when I speak to clients, I don't speak to them about one project. I speak to them about a series of projects so I can load my factory for a consistent flow. For procurement, we don't want to overspend on the cash flow here. So we're procuring in batches and a slow cash burn throughout the project. This is something that we have to align with our contracts then and our clients. And then the piece that's dear to my heart, I used to be a design manager before, the more time and effort you spend in design, the better all the rest downstream flows. So if there is anywhere in the process where you as an investor or me as a supplier should spend time and money, it's in that design process. An error propagates all the way through, and that's nothing that we want to pay for. If you're a client now and on this call, how can you prepare for engaging in the modular contract? Well, first of all, you need to understand the cash flow I just projected. We will take you through that discussion. You, on your side, as a client, will need to have a design team too, because modular is not the answer for everything. We typically don't do foundation works and roofs and so forth. So there are bits and pieces that needs to be designed outside of the modular parts as well. If you want this to go smoothly, you repeat yourselves as much as possible. Some people think that's boring. Some people think that's really efficient. Let's have the discussion. And the large ticket items for you will be the transportation and the site process. If it changes and if it's access problems or if you move the timeline, that's going to affect everything here. Control of these and certainty around these will help you produce a modular project. Your 75% of your project can be tied up in the modular portion of it. This is a lot. So you're placing a lot of your budget in the hands of one supplier. So we spend a fair bit of time discussing client-supplier relations and how we can ensure collateral for this. Now, don't change your mind. During the project, you do not change your mind. You do not walk into the factory floor and say, I want to move the door. That's way behind on schedule, and the follow-on effect of you saying that is that I probably have to change out 200 modules now and move the door. So that will be a hard no, and that's why you should spend so much time upfront in design. It's for you to be sure that you're getting what you want. Now, this one on collateral we already discussed. Let me move on because I have a tendency to talk way too much. It doesn't make sense all the time. So if we're looking at this from a sustainability standpoint, which we should for this seminar, this is not a one-size-fits-all solution, by no means. You should be looking for design repetition. You should be looking for areas where there are shortages of construction contractors, meaning you don't have much domestic supply. You should look at geographies with high demand. And you should look at where do you have the high labor rates. Labor rates in Poland are not as high as they are in other parts of Europe. So I have a delta there that I'm working with. That's why we're here. And then locations with little supply overall. I have a fair amount of islands in my pipeline. They are islands in the Caribbean. I just told you Iceland. I have projects in Ireland as well. And we're working on islands outside the coast of Africa. They are perfect petri dishes for all that you see here on the screen. But there are also countries who sign up for one or more of these conditions. This is a question many ask. Will modular construction become the norm in the future? And some people say everything should be modular. I've been in this industry for 25 years. I will say that's probably very unlikely that you're going to end up with that. Modular construction has limitations. Not all construction designs can be modularized or should be modularized. From a sustainable society perspective, why would we want to do that? We also want concert halls, and we also want open spaces for schools and, the arenas. You don't want to modularize everything you see, but there are those structures that do make sense, and let's look at them. Not everyone can invest in a factory either, and not everyone should, given the technology that we need to use them. An infrastructure as a sector, that's a large sector where it doesn't really work all that well with modular solutions, even though there are exceptions. And we live in a world where 50% of everything that's done in Europe in construction is actually refurb, which means, that's another challenge when you have to walk into existing structures and start work. Then we have the pros then. What are the pushes for a modular solution? Well, construction workers are not at hand and they are not increasing as a group worldwide. Digitalization will remove work tasks that used to depend on manual labor, but it also forces a good amount of definition into modular. The higher levels of compliance and realization of that golden thread sits really well with modular. And the reason is that I, as a modular supplier, I need to keep track of everything to make sure that it ends up in the right place. And that happens to align very directly with what is said in standards like ISO 9001, for which I'm certified, for example. And that provides a lot of certainty for clients that come in to understand that I need that delivery system as much as they do. There are, of course, some tricks of the trade, so let me share. And some of them are backwards. Spend that time in design. Don't rush. Just don't do it. You have that money. It isn't all that much if you start looking at the overall project here. Make sure that you have the proper resources and the proper expertise in design. Let's do a feasibility study. We offer this regularly to our clients and make sure that they are telling you, the suppliers are telling you, if they can get this done and if it can be rejigged to a modular construction approach. This one I would love for everyone to do. Bring your insurance company and your bank with you early. Many project discussions have ended up with a no on certain details here. And you may have spent so much time and effort into the project that you're actually really disappointed when you end up with a no from these heavy institutions that need to back you and your project. And then spend time on coordination here. We have wonderful BIM tools today. We have wonderful BIM managers today. We understand how to use digital technology to work with each other. And modular is one place where that pays off heavily. An error multiplies here. So let's make sure that we don't have them and that we see them early. Having experienced suppliers is going to be key for you for a successful project here. I trade internationally. I don't have any domestic market. I have never delivered a project in Poland, which means I have to handle all the different building codes that are in my jurisdictions. So that means I also have to have a strong engineering team that's supporting me. I need to have careful tabs on the transportation. I need to understand what the local jurisdiction is doing and wanting, because they always have their interpretation of the code. And I need to understand how to work with tariffs and VAT. Was I happy when the changes happened over in the US? Not particularly, because it changes the way you can do business, of course, on an international scale. Right? Isn't it super counterproductive now to ship modules from a sustainability standpoint? This is one of the questions I get almost every project. You're just shipping air. Doesn't make sense. So we have then made analysis on that. And I know this is probably shallow for some of you, but we have made a case study establishing the kilograms of carbon dioxide equivalent per square meter for our modules and compared that to the European standard project. And we are then below by roughly 35%, I would say here. This is a project that we produced in Germany, and we include all the transportation in the analysis. So all the diesel, all the back and forth with the materials to the factory first and with the modules to the site later is included in this carbon footprint analysis. And it's important to understand that I think this framework that we have here is really helpful, where you have the different stages of a life cycle included in that analysis, and it's set up for success and for comparisons. Now, we are a company, VBC, we now, is a company who's also producing wood modules, and we do that over in the US. I only do steel here in the EU. So we compared internally as well. And of course, no surprise here, a wood modular project comes out at a much lower carbon footprint value than a steel module will do. So I'm keeping tabs of a particular development in the northern part of Sweden and in other countries too. We are now establishing steel mills and furnaces that are not fueled by coal, but are driven by hydropower. And that will change this whole carbon footprint discussion once they come online and have ramped up their production. That's the last slide. Thank you so much for listening, and I'll be keeping tabs of the Q&A for any questions, and I'll hand back to you, Jamie.
Brilliant, Helena. That's a fantastic presentation. So much great advice for different stakeholders within this sector and that, and yeah, and even down to don't forget your banks and your insurance that a lot of people forget. And actually, in our last webinar of this series, we will have one of the major insurers on as well, giving a talk as well. So people will be able to challenge them as well and ask questions on that. But it's and also very interesting that you have set up in a country producing modules, but actually are not delivering modules within that country as well. So I'm sure there's lots of questions for you, and we'll pick up on some of those in the Q&A. But please, if you do have any questions for Helena, then please do pose them in the Q&A at the bottom of the screen. So we move on to our second presenter, Gareth McMeekin, who's a strategic and innovation manager at BuildWright Modular Concrete Homes. And he's going to talk to us about the 3D volumetric concrete solution. So over to you, Gareth.
Sorry, mic muted. Can you hear me now?
Yeah, perfect.
Thank you, Jamie and Helena. So I'm going to try and give you a quick overview of kind of who we are and what we do, and this idea of delivering sustainability through scale of volumetric. Our pedigree is quite different to Helena's in terms of our business. We're an SME here in Ireland. We have grown up through the concrete industry, supply of components, and we remain a family business rooted in County Monaghan. And that's a different pedigree to a lot of the folks who operate, especially in the volumetric modular space. So there have been challenges with that as well. Our history is 40 years of panelized production, everything from slats, walls, stairs, increasingly industrial buildings, and so we serve the residential and commercial and agri sectors throughout Ireland and the UK with our panelized production, and then the volumetric product BuildWright is a smaller part of the business, but growing particularly at the present time. When we kind of launched the BuildWright product, we're not big on vision statements and things like that, but we tried to summarize what we were doing, and our aim really is to make building simple through innovation and excellence. And hopefully, if you were to visit some of the things that we built, you would know a little bit about that. So just a quick overview of the product. A lot of the work that we've done to date, we've been producing volumetric modules for about 6 years at this stage. A lot of that has gone to private one-off developments, and the reason for that is the difficulty in the buy cycle of larger projects. It's really only after 6 years of work, and it's only in the last 6 months that we have started to see more of those multi-unit developments coming through. Top shot is a picture of our factory. There is each of those is a concrete enclosure wrapped in external insulation. And so you got a completely concrete structural frame, and then you've got pictures down below the kind of finishes typically that you're getting coming out of the factory. So modular is a very broad term, and a lot of times people think about the fully finished article, and then what they actually get is panels which need considerable work on site. We're coming out of the factory pretty much fully finished. Typical production cycle is somewhere the order of seven weeks for 7 stations in the factory to move a module through from a completed design to ready to go to site, and then roughly the same time again on site. A lot of that time on site is largely about getting weather right for render finishes, and waits for service connections and that kind of thing. The modules are transported, as you can see here, maybe not with beds and chairs in them, but with all the rest of the finishes in place, so that it's really just a case of joining up the gaps between the modules, and then connecting things like services and external renders. So things like walls are painted, kitchens are in, bathrooms are in, flooring is down. So it's a pretty complete system. This was a slightly larger project where there were 12 apartments delivered to a hotel site. Each apartment was a 1-bedroom unit, self-contained, for weekend lets and that kind of thing. As Helena mentioned, hotels find the early occupancy attractive, and so this was 12 units, 12 apartments delivered from site works. From site works commenced until the units were occupied was about 12 weeks, so an exceptionally fast program, and it allowed both an early release of those things, plus it was an existing hotel site, and we were able to minimize the disruption that was caused. So we've done quite a number of smallish projects, council sites. You can see a train carriage that was built, and then lots of one-off houses. So that's kind of where we've been at, and certainly this year a bigger part of our order book is heading into multi-unit developments. Those will be going to site quite soon. The topic for today was really this idea to deliver sustainability at scale through 3D volumetric offsite construction. And I want to take 2 slants on answering that. Is why I do believe that there is an option to deliver sustainability at scale through this system, and then just briefly to look at how. And the reality is, I do believe we need to do things differently. And I pulled in a slide that we put together back in, I think, 2016, whenever we started to look at why we as a company should look at doing more than just panelized construction, and what the challenges in the industry were in 2016. Skill shortages, increased build and finish standards, health and safety management, waste material efficiency and cost, and financial uncertainty. Now, modular does not fix financial uncertainty, as has been already mentioned. Sometimes it makes it a larger issue, but the reality is modular speaks to all the rest of these things, and none of these issues have diminished over the last 10 years since we first made this list. And as I look at modular, especially volumetric construction, I'm increasingly convinced that the things that need to be utilized in order to make construction better happen best in a factory environment. We need to train more people, and it is the right place to train them in a safe factory environment where they've got not only their trade mentors but good management oversight. It's the right place for workers to have the right balance and the kind of facilities that the modern world expects. When we go to automation on a building site is so difficult, and there is so much that we can do with robotics and automation in the factory. When we go to think about our products being a continuous improvement cycle, not just staying static, but continuously being innovated, again, having a team there together where trades talk to technical staff and detail and technicians can look at problems together around a thing all in one place, and all at a kind of drop of a hat's notice to come together around a problem. It is the right place for continuous improvement, and it's the right place for proper oversight that's all the more required. And why is volumetric specifically of interest? Well, the statistic came off the internet, and it's maybe not that relevant as to the finer details of it, but it highlights that the other forms of modular that aren't volumetric make incremental changes to how things work, and volumetric is the one that makes a huge difference. It is a different way of doing things. It's not a micro innovation. It's not a slight transition. It is a completely different way of doing things. It is absolutely the hardest way to do modular. It takes so much work to get it right, but it should be the place where we see the proper gains over the long term. And so how do we deliver, or why do we deliver, why is it possible to deliver sustainability at scale using volumetric? I completely believe that it is. And as I started to think a wee bit about the how, then to frame it around something, this acronym came to mind, and I think it in itself speaks to the situation. How do we deliver sustainability at scale through 3D volumetric offsite solutions? We need to trust the systems that are there. And I don't mean blind trust with no science behind that. I'll explain it. But one of the huge problems is at the minute is a lack of trust in the systems. And so my trust acronym says that we need to test the system properly. We need to recognize it for what it is and what it's not. We need to use it and learn by doing. We need to scale that, and then we need to continually tune the modular offering. As a company, we're rooted in the concrete trade, and so the first test that we applied before we ever began modular production was the customer test, and people want to live in a concrete home. Apart from any other arguments, the people who invest their money, far and away the majority, want that resilience that they've learned as in concrete. And so we understand we won't supply every need in the market, but that idea is tested by our customers. And then to say a word about agreement certification. I hope that most people are familiar with what it is, although I think there's an assumption that people know what agreement certification is. For me, it was a 4-year ordeal to try and get the system certified. It is no small matter. But it was a wholly worthwhile experience for us, and my going through that would teach me that people who have achieved agreement certification for a volumetric build system, the scrutiny has been done to a level that would allow the general engineering and design professions to trust the system. And I think it's important just to make that distinction. Agreement certification is talked about, and there are two types. One is approval for systems, which is so very detailed because it takes into account every part of the build, every junction, which in component certifications is not nearly as thorough, because you only look at the one item. Your whole build has not been reviewed in that way. So absolutely, we need to test, and agreement certification is a heck of a test for modulars, for a build system. I've got a strange picture in this because I took my 4-year-old kid to the newly developed Clonus Canal walkway, and she had to bring her scooter with her. And I was just about to do a presentation on modular systems whenever I watched her. She couldn't use her scooter, so she brought it and carried it around with her. And I thought, that's a little bit like what we do with modular systems. An awful lot of the time, we carry the modular system around and we never get the benefit out of actually like moving on the scooter, like my daughter missed out. And we need to recognize what volumetric offers. It's not a swap out of a component. It's not a replacement for traditional construction in every scenario. It's a different approach in every aspect, in planning and design and build and finance. It has real benefits, but it's detailed differently, and we need to understand that we can't always go for a new solution and make it look like what everything has done in the past. We're very attached to our details, and we need to be careful about that we don't try and superimpose stuff. Use, we've already mentioned a little bit. So part of we need to use it, and we need to have a system that allows us to use it. At the minute, so many of the modular suppliers sit outside of the standard supply chain, and they get drafted in too late in the process. But if you haven't actually done a modular project or a volumetric project, you need to do one to learn. It is like that is, if we're going to really get the benefits and the sustainability out of the system, it needs to be used. We need to scale the solution then, and scaling the solution is not taking what we've got and just going bigger with it. We need to start and rethink designs from the bottom up. How does this really work in a box coming from the factory? How do I make a nice design of that? Instead of frustration at trying to work with these constraints, we often need to take a blank canvas, and we did that with a couple of projects here. Just that's a semi-detached duplex unit that fits nicely in boxes and doesn't compromise the design. That's a terrace unit, and that's another apartment building. But the design needs to come from the ground up, and it needs to take modular constraints into consideration from the very beginning. And then we need to tune the system as we go. The problem with certification, and certification is great, is it makes you freeze development. And if we are going to get the sustainability benefits out of these things, we need to go back around again and again and again and innovate to reduce carbon footprint, to reduce wastage, to make things more efficient. And we need to understand volumetric as a system that continually gets tuned. So that's kind of my conclusions. That's my recommendation. We do need to learn to trust the system. That's based on thorough testing, recognizing what it is, learning by doing and the use of the system, and scale. Helena already talked about the absolute need to keep factories full, because suddenly we're going to lose a whole lot of so many of the modular businesses are running on enthusiasm at the minute, and that won't last forever. They need scale, and they need projects through the pipeline in order to make them work, and then we tune it. So that's, I don't know how long I've taken, but that's a rapid fire tour of kind of what we do and the 3D volumetric concrete offering.
Brilliant, Gareth. Perfectly on time. Well done in there, and really great presentation in there. A long journey for you guys, 6 years or so to get there, 4 years to be certified. But also great to hear the value you see out of going through the certification, and that I suppose helping with the trust part of it. That if you have gone through an argument certification for a system like your own, that will means that it has been a very robust system, that your analysis or review that you've gone through to get there. I also like that use trust for test recognition, you recognize, use, scale, tune in. That's really, really neat. I think that covers a lot of things there in it. And great to hear the why, which obviously has come up several times for people, the why, but that how to do it and how to scale it up. So lots of great stuff in there. So please, if anyone has any questions for Gareth or Helena, please do post them in the Q&A function at the bottom of the screen there, and we'll deal with them after all three presenters. So we're on to our third presentation. Now, third presenter is Dr. Barry Heffernan, who's Chief Operations Officer at OxyMem, who's a DuPont brand, and he's going to talk about their OxyMem MABR system for the wastewater treatment system. So, modular and 3D volumetric, we obviously, there's a lot of concentration on buildings and delivering buildings, but actually there's huge opportunities around standardizing and volumetric approach within infrastructure such as wastewater treatment systems, water treatment systems, the energy sector, and so on. So Barry's going to show us one of these systems and what they have developed in there. So over to you, Barry.
Thank you, Jamie. I hope my screen is coming through. So yeah, something that's quite a bit different from what Helena and Gareth have shared earlier on. So we're moving over into wastewater treatment. And on the screen here, I'm showing a picture of our module. That's literally what we call our product, and it's been dropped into a wastewater treatment plant in the UK called Monkmore. So today I'll try to more or less give a little bit of a history background to what wastewater treatment is, and then how the MABR can be a modular system to upgrade existing wastewater treatment plants. Before I do that, sorry, I'll just give you a little bit of background on OxyMem and its journey. OxyMem is an Irish company. It's not very old. It was only founded in 2013. Before that, the membrane-aerated biofilm reactor was just a concept that existed in the lab. And I'm showing the OxyMem journey here, so we can see that there's the lab years there. That's a picture of a lab reactor I had when I was doing my PhD in UCD, when this was just an idea, and it is indeed a 50 milliliter syringe that you're looking at there. So back in those days, I didn't think I'd be sitting here today talking to you about a modular MABR solution. The company was founded in 2012 when Wayne Byrne, our founder, our CEO, met with Enterprise Ireland and Owen Casey, my PhD supervisor. And then we had a couple of years where we were trying to figure out what to do with an MABR. We went through an IDC stage where we had members inside in that. We thought we could be a package plant solution, but that really didn't work for the municipal wastewater treatment market. That's primarily because the vast majority of wastewater treatment plants exist already today. The activated sludge process, the main process that's used to treat wastewater, that has been around since 1914. So in Europe, North America, and vast swaths of the planet, most wastewater treatment plants exist. And their challenge is how to do more in those wastewater treatment plants. It's not to build new wastewater treatment plants. So then in 2020, we pivoted from trying to make these modular, let's say, volumetric package plants to actually to see how we can use our product to drop into wastewater treatment plants and to take advantage of all that embedded carbon that's in the concrete, in the ground already. So that's a little bit on the background of where OxyMem comes from. We were acquired by DuPont in 2019 and have been slowly progressing and growing, and we sell right across the globe from New Zealand right the way through to Calgary in British Columbia. So basically, what is the MABR? To put it succinctly, maybe it's what we're trying to do is to sweat the asset. And this is a picture of a plant in the UK. It's called Site. It's one of our first references. I just might see if I can show here. So here we've got 9 MABR modules, and here's the 10th one that's installed in the tank. And this maybe is shows the real advantage of the OxyMem MABR. We're dropping these modules into the existing wastewater treatment plant, and at the same time, the plant stays live all of the time. So we can see that there's movement bubbles here in the water, and that's where the aeration is on, and the tanks are full of water. And most other technologies that are used for upgrading wastewater treatment plants, you have to drain the tanks down and you have to empty them, and that can result in a lot of costs, a lot of downtime. And what do you do with the wastewater when your plant isn't available? So one of the key advantages of the MABR is we can drop into existing wastewater treatment plants without taking them offline. It means that the upgrades can be very fast. And on top of that, we have an added advantage is that we have really low energy usage. So just how does the product look? So this is our membrane. It's made from silicone. It's a dense material. There are no pores, but oxygen can diffuse through it. So in wastewater, you need two things to clean the wastewater. You need oxygen and you need bacteria. So the MABR serves both functions. The bacteria grow on the membrane, and we supply oxygen from inside these fibers, and it diffuses out directly to the bacteria, which grow on the membrane and then treat the water. Versus conventional technologies, one of the key advantages we have is that the oxygen is being transferred directly to the bacteria. Normally, the wastewater treatment plants use bubbles, which you could see a little bit of that in the previous slide. You could see that turbulence at the top of the water. But the transfer of oxygen from a bubble is very inefficient. It depends on how big the bubble is and how high the water volume is. In this case, we don't have to worry about that because we're transferring the oxygen directly to the bacteria. So we can use less air at lower pressures, which means we use a lot less energy. So in addition to helping the plants treat more flow and load in the existing structures, we can also reduce the energy use. And then, as I said, this is our module itself here. We've manufactured these in Athlone, and then we ship them all over the world. The product itself was designed for shipping. We can fit 10 of these in a 40-foot container, and it was our key design criteria was how many of these modules we can get in a container to optimize shipping. In terms of how we do upgrades, I have a short video here. Hopefully it will play. And this is a plant in Canada, and it just shows how quickly and easily we can upgrade the plants. So we manufactured the modules in Ireland, shipped them to Canada. All of the steel work was fabricated offsite and then installed, and then we dropped in 8 of these modules in about 2 hours and upgraded the plant really, really quickly. But to go on to this, I mean, I'll just take a little bit of step back and describe what the challenges the wastewater treatment industry are facing, and then a little bit of the science behind it, and then I'll show some case studies for how OxyMem's MABR can solve that. So I'm lucky enough to meet with a lot of owners, operators of wastewater treatment plants, and they tell you your problems, and that's always a gift for any manufacturing company. If you know what a customer's challenge is, you can potentially help solve it. Possibly the biggest challenge for the wastewater industry is that the aging infrastructure. Many plants were built back in the 50s, 60s, 70s. They were built when the standards were lower, and they were built when the population was smaller. So right now, those wastewater treatment plants can't necessarily handle all the flow that's going to come to them, or they can't handle the new effluent limits they're going to get. On top of that, energy is always a concern. It's one of the main operating costs is the energy for operating the fine bubble diffusers. Emissions are increasingly becoming a concern, less so the emissions associated with producing energy to power the blowers. As grids go green, that's less of a concern. More so with the process emissions. So in wastewater treatment plants, you can produce carbon dioxide, which is short cycle carbon, but you can also produce nitrous oxide, laughing gas, which has a warming potential of 300 times carbon dioxide, and potentially methane, which is 25 times that of carbon dioxide. And then skilled labor is an issue, and I guess more than anything, the wastewater treatment plants have all these challenges, but they also have to try operate on minimal budgets. So all these things together make it quite challenging for wastewater treatment plants. If we take a further step back and look, what is the science behind that challenge? Just go really back to the beginning, that the building blocks of life are here on the screen. There's 5 main elements made up of most organic life. It's carbon, hydrogen, oxygen, nitrogen, and phosphorus. In wastewater treatment, you're really looking at trying to remove carbon, nitrogen, and phosphorus. The phosphorus basically doesn't have a gaseous phase, so we're really focused on carbon and nitrogen. So we're really trying to get them from being in a solid state back to a gas, and basically we're trying to speed up those processes. Of the two, the bacteria that remove carbon, they get a lot of energy from that. They grow really fast. But the bacteria that remove nitrogen, they're called autotrophs. They get a lot less energy from using nitrogen. So in which case they grow a lot slower. So basically, whenever you're trying to treat more flow or you're trying to get a better effluent quality in a wastewater treatment plant, you're always worried about the bacteria that remove nitrogen. They're called nitrifiers. So if a wastewater treatment plant fails, it'll fail most of the time because you're washing out the nitrifiers. So what do I mean by washout? Basically, the bacteria double in a certain amount of time. Typically, it could be for nitrifiers, it could be 5-6 days, a doubling time, depending on the temperature. The sludge age basically measures the average time the bacteria stay in the system, and it's a pretty easy calculation. It's the mass of nitrifiers in your tank divided by the mass of nitrifiers that are washed out in the excess sludge. And if you have a sludge age of 10 days, typically you're okay. And if you're less than that, you may need to be concerned. If anyone is more interested in that, I can discuss it offline or somewhere else. I'll just go a little bit fast through it today just for the time limit. But basically, this example here shows what happens when you have to treat 50% more flow in a wastewater treatment plant. The SRT, that's the sludge age, the amount of time the bacteria in the system, it went from 6 days down to about 3.5 days. But if we take a look at the effluent BOD, that's a measure of carbon in the effluent, there's almost no change. It hasn't had any impact at all. But if we look at the ammonia concentration, it's gone from being really low up to 12 milligrams per liter. This is really high for ammonia concentration, so the plant is not performing anymore. And that's because the nitrifiers are getting washed out of the system. So we need to do something about that. So what can we do if the nitrifiers are getting washed out when the sludge age is low? So one approach is to do what we've always done before, and is to build more of what these called conventional activated sludge systems. So that's what I'm showing on the screen. Over here we've got these tanks here are the biological tanks, and these are the settlers. And they can be huge tanks. They take up huge volumes, huge amount of surface area. There's huge amount of concrete goes into them, steel, everything else. The advantage, they've been around for 100 years, and they're well understood. So the industry tends to have a habit of just do what you know, and do it again and again and again. But there's a huge amount of on-site work that needs to be done with it, civil works, but it works. To be fair to it, the technology works. About 40 years ago, this technology called a moving bed biofilm reactor was developed. It's also a biofilm system like what OxyMem does. The difference is they've got these small little carriers, these chips, and the bacteria grows in them. And you can dump them into a wastewater treatment plant, but you can't just dump them in. Most of the wastewater treatment plants are long, narrow channels, similar to what I showed in the first video. And if you just dump those carriers in there, they're all going to end up at the latter end of the tank, and they don't work. So you actually have to empty the tanks, put in all of these partitions, and put in these sieves, which maintain the carriers in their zone. And once you do that, you also need to increase your energy use compared to what you've had before the carriers went in there, because you need to use energy to keep them in suspension. So it's not modular construction yet. You have to do physical work on site, and you're going to use more energy to do an upgrade of the plant. And then the third system is what they call membrane bioreactor. And essentially, instead of using the settlers, those big circular tanks I showed previously, you can use these membranes here, ultrafiltration membranes. They can be very compact into a small tank here like this. And they allow you to have a lot more biomass in the system, and biomass is what you need to treat the wastewater. The negative things about these is that there's even more energy requirements than a moving bed biofilm reactor. You have to aerate the fibers really aggressively to stop them fouling. And it's also not, you can't necessarily drop into the existing structure. You need to make a membrane tank. Again, they work, but they are quite energy intensive. So then the alternative is we use an MABR, and the MABR specifically provides nitrifiers. So I'll do a little bit of science behind that. So here we have our oxygen that's going through our membrane, and then we get the bacteria grown on the membrane. And out here we have the bulk liquid, the water, where we have our ammonia and our carbon, acetate as an example here. And what happens is the ammonia diffuses in through the biofilm, meets the oxygen coming through the membrane, and we get nitrifiers growing. Acetate also can come in, and normally the acetate would win because the bacteria get more energy from using acetate than they do ammonia. But we get this kind of virtuous circle happening where when the ammonia is being treated, it produces nitrate NO3, which has to diffuse out through the membrane. It meets acetate coming in, and we get denitrification. And we get this virtuous circle where only the ammonia gets into the inner layers. So we're selecting for nitrifiers. So what the MABR does is it gives you the exact bacteria you need to upgrade the plant when conditions become challenging, when you're trying to treat more flow load or trying to achieve a better effluent quality. So then just some examples of how it works on projects. We have projects all over the world, but the two I'll show are from the UK. They're relatively large installations, and they're just some interesting civil works that we had to do to make it work, or maybe not civil works, wrong word, mechanical works. So this plant is called Monkmore. It's in the UK, and it was started up in 2024. Their challenge was they were getting more flow because the population was increasing from about 116,000 people, equivalent to 146,000. Plus, they got a new total nitrogen limit. In order to solve those two challenges, Severn Trent, the operator of the plant, decided to decrease the operating sludge concentration. It means there's less pressure on the settlers so they can handle more flow. And then they added iron chloride into the aeration tanks to precipitate out the phosphorus, which means they have more sludge production. And what those two things mean, to get to the end of the story, basically, is that your sludge age goes down. And when your sludge age goes down, you're putting your nitrifiers at risk. So their solution was to drop in 48 of our OxyFast modules to treat 162 kilograms of ammonia per day. And these are the modules here on site. The modules were fabricated in Ireland, and the steelworks were fabricated off-site in the UK. And there was some clever engineering to manage to do this upgrade without taking the plant offline. I'll show them in the next slides. And this just shows one module getting installed. So this shows the tank. One of the challenges for OxyMem is that you get what you get. The tank geometry can be anything. So in this case, it was relatively nice. There was a wall over here, which could be used to support the modules that hang from the top of the tank. There was also a wall here. Unfortunately, there was also a walkway here with cable trays and everything else on it. And the client didn't want to take this off. It would be a lot of challenges. So instead, we made this piece of steel that was cantilevered that were able to slot underneath the walkway, and then drop in these steels to support the MABR modules without ever taking the plant offline. So you can kind of see some of the design work here. This is the walkway, and this is that cantilever structure I'm talking about, which slotted underneath. And this is the steel where the MABR modules sit on. And then the next slide just is a quick video showing the install of the modules. So when it came down to doing it, all the steelworks is in place, all manufactured in factories off-site. So were the modules, and then 24 modules were installed in a single day. And as you can see, the fine bubble aeration is ongoing all of the time, so the plant isn't stopped at all for a single second during this upgrade. I've decided not to show you the performance of the plant. It has worked. We've removed more ammonia than we needed, and they're getting good effluent quality. And if anyone's really interested, they can connect with me and we can go through in more detail. Then one more case study. This is with Hollandhurst with Wessex Water in the UK. And their challenge again was somehow similar to that of Monkmore. They had to treat more load, chemical oxygen demand, carbon and ammonia. And land was a real issue here. So this is the Hollandhurst plant, and it's completely built out and surrounded. So you can see there's a road here, and over here there's a golf course. These are their existing activated sludge lanes. They're not appropriate to drop in those MBBR carriers I mentioned earlier on because they're long, narrow channels, really, really difficult to do an upgrade. So if we take a look at it, the conventional approach would have been to buy land from the golf course and construct more aeration lanes and more settlers. but that obviously is not, it's far from an ideal solution. That the local golfers don't want to lose their golf course. And then the wastewater treatment plant doesn't want to pour more concrete if they can avoid it. So instead, the solution was to drop the MABR modules into these existing tanks to upgrade the facility. So again, their main challenge was they had to reduce the MLSS, so sludge was going down. We installed 50 OxyFast modules. This is the module here. On this particular site, the Monkmoor site, they didn't have walkways on top of the modules. They were able to use to make the connections, to use the man basket. In this case, the client would prefer to have walkways on top of the modules. So we had to engineer this solution where we literally inbuilt walkways on top of the hangers that we used to install our modules, so that you could connect all of the piping. And this just shows some images of the construction, so you can see, we can see the walkways and access on top of the modules. This plant has also started up, and we just passed our performance test a couple of weeks ago. So that's basically it. For me, just showing that we can upgrade existing plants while they stay live. Using a modular approach with products that's manufactured alone in Ireland, shipped all over the world, and it speeds up the time for upgrading these plants. Reduces carbon footprint as well, because you're not pouring new concrete into the ground. And I guess the other thing is that we can also do incremental capacity increase. So we can help end users only treat the additional load that they have, whereas maybe in the past, if they were building new wastewater treatment plants, they maybe have over-designed plants and put in more flow, put in more tank volume than they actually required. So that's it, and thank you for your attention.
Thanks. Brilliant. Thanks, Barry. Fantastic to see that. I suppose we have invested a lot of time and money into these plants, and by taking this modular technology and implementing them, that we can actually get more out of our plants. And that's so obviously lots of our towns and cities in Ireland, the UK, and further afield are they're limited in terms of how much building we can do, how many more buildings, schools, industry that we can put in there because of the capacity of wastewater treatment systems. And if we can operate our systems more effectively and more efficiently, either by retrofitting them like through your system, or by operating them slightly differently, then obviously that opens up potential then for our towns, villages, to grow using existing systems, which are far more sustainable, far more cost-effective way of doing things. So great to see, and great to see the success in there, and and that you are actually manufacturing something that came out of a lab originally in Ireland from UCD, then that you actually do the manufacturing in Ireland and be able to compete worldwide, or well, internationally, at least in the UK, and have impact there. So that's fantastic to see. So we're over to the Q&A session now.